Hello, welcome back once again. Today we're going to solve this exponential equation with a negative base. Isn't that interesting? We have negative 5 to the power of x equals 5. And here, we're going to solve for the value of x. Without even saying much, we already know that x must be a complex number, right? Because there's no how x will be real. Negative 5 to the power of a real number to be 5. Is that possible? That is not possible. If you say 1, negative 5 to the power of 1 is negative 5, which is not equal to 5. So x must be complex. Okay, now in this video, let us first solve for the value of x, then we can make a general solution, right? So here we have negative 5 to the power of x. This is equal to 5. Now we're going to natural log both sides, but before that, we need to take note of something really cool. We know from Euler that negative 1 is equal to e to the power of I pi. So this is telling us that if you natural log both sides, we get the natural log of negative 1 will be equal to the natural log of e to the power of I pi. And moving this power down here, we have I pi times natural log of e, and we know that the natural log of e is 1, which is equal to I pi. Therefore, the natural log of negative 1 is equal to I pi. Okay, now let's see how this is going to help us. Now from here, natural logging both sides, we get the natural log of negative 5 to the power of x. This is equal to the natural log of 5. Move this power down with the power rule for natural logarithm. So we have x multiplied by the natural log of negative 5. Then this is equal to the natural log of 5. Take note of this here. We have x, the natural log of this is negative 1 multiplied by 5, then this is equal to the natural log of 5. Let us take note of this. The natural log of a times b, this is equal to the natural log of a plus the natural log of b. So from here, that will be x into bracket, the natural log of negative 1 plus the natural log of 5. And this is equal to the natural log of 5. So we can see from here that we have arrived at this place, the natural log of negative 1, which we found here to be I pi, right? So here we replace that with just I pi, then plus the natural log of 5, then this is equal to the natural log of 5. To solve for x, we need to divide both sides by I pi plus the natural log of 5, here by I pi plus the natural log of 5. This cancels this, and here we have the solution that x equals the natural log of 5 divided by I pi plus the natural log of 5. Okay, now what about the general solution? Because I'm very sure that this equation has infinitely many number of complex solutions, right? So let's see how we're going to do it. Now let us recall that this equation, negative 5 to the power of x is equal to 5. And natural logging both sides of this equation, we get natural log of, okay, now this is negative 1 times 5, right? Then raised to the power of x, then this is equal to the natural log of 5. Okay, now if e to the power of I pi is equal to negative 1, we can see that this is also true for e to the power of 3i pi. Also e to the power of negative 3i pi, e to the power of 5i pi. That is for odd multiples of this I pi, right? So this is actually telling us that negative 1, we can generalize this as e to the power of I pi, then times 2n plus 1, where n belongs to the set of integers, right? So now with this idea here, this negative 1 here, we can write it in the general form as it is in this argument of this natural log. So here we have the natural log of, that would be 5e to the power of I pi 2n plus 1, right? Then raised to the power of x, then this is equal to the natural log of 5. Now moving this x down and dividing by this, so we get x is equal to, as the general solution, natural log of 5 divided by the natural log of 5a to the power of I pi into bracket 2n plus 1. And here n belongs to the set of integers. And here we have the general solution. Thank you for watching. Please kindly subscribe to my channel. Also like, comment and share. Bye bye.